second session of the experience session. And we're going to start with a big performance comparison of service mesh frameworks, the MTLS test case. Welcome.
Hi, hello everyone. I'm Ofek from Tel Aviv University in Israel, and today, as was already presented, we're going to talk about performance comparison of service mesh frameworks in the MTLS test case. So let's start. Before we can start, we need to understand what service mesh is. In the past, most applications were monolith, meaning that every task the application needed wasn't on the same software. But this was very hard to develop and maintain. So people came with the idea of microservices. In this approach, every task the application needs is in a different service. So this way, we can develop and maintain each service independently and even treat them different. For example, giving them different resources or different permissions. But we need something that will manage this infrastructure. This is called Kubernetes. The Kubernetes manages the scaling and the deployment of these services, but it does not manage the communication between them. So if you would like to add an encryption or read write, you would need to do it on your own. Therefore, people came with the idea of service mesh. Service mesh is another tool with built on top of Kubernetes, and it manages the communication. So the service mesh deploys a proxy for each service, and now the communication between the services goes through this proxy instead of directly. This way, the service mesh can manage the communication, add encryption, read-write, timeouts, and many other advanced networking features. So we understand what service mesh is, but let's see if people really use it. So a survey of CNCF in 2022 checked how many organizations really use service mesh. They found out that over 90% of the tested organizations said that they either use service mesh or blend it. In addition, they also checked what are the leading features or capabilities that leading them to adopt service mesh. They found out that the top one reason was security, like MTLS. And that's what our talk will focus on. So, as you can see, there are many types of service mesh. I gave you the top 4 most popular service meshes, and that's what our talk going to focus on, but there are more. And each one of them work differently, in different ways. There are different models, as you can see here, different proxy, different MTLS libraries. There are many differences. So we saw that a lot of companies want to use service mesh, but how can they know which one to use? Let's see if our related work can help us solve this problem. Indeed, each service mesh company had evaluated its performance, but this was not done by a third party, and this is very hard to compare to different service meshes. In addition, only few comparisons have been conducted, but nearly none of them was by a third party. And as you could guess, when a company does a comparison about their product, they're always win. Many studies also evaluated the performance overhead of service mesh in general, but this was not done with a comparison to other service mesh. So it's very hard to know which one to use. In addition, the performance impact of MTLS in general and in service mesh was also studied, but again, without a comparison to different service meshes. So there is no good service mesh comparison. So let's make one. We'll start with some background. Before we can try to compare different service meshes, we need to understand what are the different models and how they differ from each other. So there are 2 main models of service mesh, the sidecar and the sidecarless model. In the sidecar model, the service mesh deploy a proxy for each pod, and the communication goes between these proxies. However, in the sidecarless model, we use eBPF, so they can deploy just one proxy for each node, even if you have many pods in the same node. Later in this talk, we'll try to understand how these different approaches affect the performance of these service meshes. So let's get to see our tests. In our test, we'll focus on three main metrics: on latency, CPU usage, and memory usage. So before we can start, we need to have a baseline test. We can compare our service mesh to the baseline and see how they perform. In each of our tests, we have either one or two nodes. We have two pods. In one pod, we have our simulated server, and in the other, we have our load generator. The load generator will send periodically a request to the server, and we will test our latency, CPU, and memory usage. In the baseline test, we won't have any service mesh, and the communication will be just HTTP with no encryption. Then we'll have our baseline MTLS test. In this test, we'll have the exact same settings without service mesh, but the communication will be in MTLS. Because we don't have service mesh in this case, we need to implement the encryption in our own, in the client and in the server. Not that fun. Then we can finally test our service meshes. We'll start by testing the sidecar model. We have two sidecar model service meshes that we tested: the Istio and the linker. In this test, we installed the service mesh, one of them, and let them do the magic. This way, the service mesh deployed a proxy for each pod, and the communication now goes between these proxies. And we did not implement any encryption, and the service mesh made encryption false. Much easier. Then we tested our sidecarless model. In this test, we have two service meshes as well. We have Istio Ambient, which is another newer version of Istio with sidecarless, and we have Cilium. So again, we deployed one of these service mesh and let them do the magic. Now, we have just one new pod for each node with a new proxy. Now, again, the communication goes between these proxies, and encryption is done by the service mesh. Now, let's get to see our results. First, let's see our results of the baseline test. What is the MTLS overhead without the service mesh? We start by the latency. Here, as you can see, there is relatively very low latency overhead, less than 3% overhead. However, in the resource consumption, we have the memory and the CPU. The overhead was about 2 times higher, just by adding MTLS without a service mesh. Now we can finally get to test our service meshes. We start by latency. We have in the first our baseline from previously. Then we have Istio, who was the worst in terms of latency of all the others, with huge overhead. As you can see, this is huge. Then we have Cilium and linker, who was about average. In second and third place, about the same, but in the higher loads, Cilium was better, and in the lower loads, linker was better. And I will remind you that Cilium is sidecarless, while linker is sidecar. Then we finally have Istio, who was the best in terms of latency, with really small overhead. As you can see, this is really small. So we can conclude, in addition, that the sidecarless model had an advantage in latency, especially at high loads. Now let's get to the resource consumption. It's a bit more complicated, so bear with me. First, we again have Istio, who was the worst in terms of memory and CPU consumption. Then we have Cilium, who was the best in terms of CPU this time. Again, sidecarless. Then we have Istio Ambient and linker, who performed about the same in terms of CPU, and was second, and got the second place. Now we'll come back to the memory. At medium loads, Cilium was third, and in the high loads, Cilium was second, as before. And linker in the low loads was second, and first, and third in the high loads. Again, linker is sidecar, and Cilium is sidecarless. And finally, we again have Istio embedded with really small overlap. Another interesting point that, as you can see, linker had a huge gap between these cases. Here, linker was better than Cilium in small amount, but here the gap is much higher. So again, we can see that the sidecarless model had an advantage in resource consumption as well, especially at high loads. However, I a bit lied to you because the results I showed only was about the internode communication tests. So let's see if we have any difference. So as you can see, every service mesh but Cilium had about the same performance in the inter and the internet communication tests. But Cilium, on the other hand, had about 2 times more latency overhead in the internode relatively to the lower nodes, to the internode. So as we saw before, the worst case. So if we did the same comparison with Istio in the internode, he was the first in latency with a tie in Istio ambient, as you can see. But he's not that good in internet communication because by design, unlike Istio and linker, SIM disables network encryption, so you can't encrypt the internet communication in Cilium. So this might be a problem for some people, but if you don't care about encryption inside your node, you're okay, and you get better performance. So we wanted to understand the significant overhead of Istio, one of the most popular service meshes. So we came with another test. In this test, we disabled each feature of Istio, and we enabled them one by one to see which feature causing the problem. In the test, we measured the maximum RPS the system can get. First, we have, of course, our baseline. No MTLS, no service mesh, nothing. Then, we enable just MTLS without service mesh, implemented in the client and in the server, the application level. As we saw before, the overhead is quite small. Then, we didn't use the MTLS, and we installed Istio, but we disabled all the different features that come with Istio that nearly everyone uses. The matrix collection, the HTTP parsing, and of course, MTLS, which is not different, but we disabled this as well. And as you can see, the use was really big. So we can conclude that the main overhead was done just by adding these proxies. These proxies add a huge overhead, and just by installing Istio, you get a huge overhead of your performance. Then, we enabled matrix collection. But this time, we had nearly no difference. Again, then, we disabled the matrix collection and just enabled the HTTP parsing. The part that parse the HTTP connections, so Istio can manage these communications. But this time, we had a huge gap. So we can conclude again that the HTTP parsing is one of the main features that cause the problem. But if you don't use HTTP parsing in your service mesh, why would you use service mesh? Then we enabled matrix and HTTP parsing, but as we saw before, matrix does not have a much of overhead. And finally, we had MTLS as well. And as you can see, even though all we wanted is just add MTLS in an easier way, but the MTLS itself does not add a much of overhead. But installing Istio and the HTTP parsing is the main thing that's causing the problem. Next, we wanted to understand the impact of the memory consumption differences between the services, between the service meshes. So we came with another test of Istio ambient. This time, Istio ambient. This time we measured how the memory grows with the number of connections, and we saw that without MTLS, the memory grows with the number of connections. Quite boring, and of course. However, when we add MTLS, we got about the same results, so we can conclude that the MTLS memory overhead does not grow with the number of connections. So let's get to summarize our results. We start by Istio. So Istio, I will remind you, is a pair pod proxy with sidecar. And as you might remember, it was the worst in terms of latency, in terms of CPU, and in terms of memory. So think again when you use Istio. And fun fact is Istio is the most popular one of all the others. And then we have Istio ambient, a newer version of Istio that is sidecarless. It had a per node proxy. This time, Istio ambient was first in terms of latency. It was second in terms of CPU with a tie to linker, and Cilium was the first one in this section. And in terms of memory, it was first again. So if memory and latency are important to you, you might consider to use Istio ambient. Then we have linker with sidecar and has a pair pod proxy. In terms of latency, it was second in the lower loads and third in the higher loads. In terms of CPU, it was second again with a tie to linker to Istio ambient, and Cilium was the first. And in terms of memory, he again was second in the low loads and third in the higher loads. So if in your test cases you have lower loads, you might consider to use linker. And if CPU is important to you and you don't want to use Cilium, you might consider this as well. However, we assume that when we will have more pods per node, we might have worse performance. But this is for future research. Finally, we have Cilium. Cilium again is a per node proxy, is sidecarless, and it was second in the lower loads and second in the higher loads and third in the medium loads. It was best in terms of CPU, and it was second in the higher loads and third in the lower loads. So if you use higher loads and CPU is very important to you, you might consider to use Cilium. And linker was better than it in some cases, but again, we assume that with more pods per nodes, we might have better performance here than linker. But again, this is for future research. But Cilium does not encrypt internal traffic. So if this is important to you, don't use Cilium. So let's summarize. We saw that each service mesh provides different trade-offs. Each one of you can choose different one in terms of your preferences. Then we saw that the sidecarless architecture give a performance advantage, especially at high loads. Then we saw that each feature we add to our service meshes add more overhead. But the main thing is just adding these boxes is the main thing that adds the overhead. Finally, we saw that the memory overhead is not proportionate to the number of connections. So now you can know how to choose your service mesh. Thank you very much. I'd like to hear questions.
Thank you, very nice presentation. Questions?
So you talked about that the Cilium is using the WireGuard and IPsec for the internode communication, right? So what are the others using? So if you're using Istio or Linkerd, so what's the encryption based on?
It's based on I think Boeing MTLS library. I'm not exactly sure which specifically.
Envoy, I think they use it.
Yeah, they're using Envoy.
Envoy proxy.
Hmm?
It's Envoy.
Yeah, it's used Envoy proxy.
Yeah, it's different levels, like level 4 or 7 or
Yeah.
level 3.
Yeah.
But so the Envoy, so the Envoy proxy is an MTLS connection.
Mhm.
This was my okay. Thank you.
Thank you for that. I think we need much more of these like benchmarking works because this is the only way how we can actually see these things. Right? So can you, based on what you found, can you draw some conclusions or some estimates on how this would behave the moment that you have multiple clusters? Because all of this work was multiple nodes, but all in the same cluster, right? So the moment I'm talking about multiple Kubernetes cluster, do you have any idea if this would worsen or be more pronounced or something like that?
I can only guess, but I could guess that the differences between each service mesh, but will be very similar to the internal communication because in the end it's quite similar. It has different nodes, but it has another cluster on top of it, but it's the same type of communication. But I could also guess that it might have bigger overheads because it's like harder connections to do and they're slower, and the overhead might be higher. But I think the differences between the service mesh might be the same.
And also, not all this tool might support inter-cluster communication because Istio, I know it support. You can add a gateway and you can allow an inter-cluster communication. Then there are other tools like Lyco, Lico, which basically use WireGuard to connect pods. Thank you. Very interesting. The second presenter.